Okay, let's try one final argument and try to solve for its validity here. Okay, so again, we're going to use our indirect truth tables here. So looking at this argument, you can see immediately kind of why it's nice to be able to do these indirect truth tables because as you can see here, we have 4 different letters, P, Q, R, and S. So if we were doing the full truth table, the longer truth table, then you would have to take 2 to the 4th power we're in, because n is equal to 4 here, and that in itself would get you 16 rows. Okay, that would be a very big truth table here. It's really nice to have indirect truth tables because when you have arguments with this many statements in it, you can just very quickly kind of do it without having to do row after row after row, and when you keep doing all these different rows, you're increasing your chances of perhaps making a mistake. So the indirect truth tables are kind of nice to know in order to do this. So again, we're going to do the same sort of deal. So we're going to lay this out on its own little table. So we'll go P and Q, horseshoe R, that's our first premise, S, horseshoe R, and then finally P and Q, horseshoe S. Okay, so again we're trying to figure out whether or not this is an invalid or valid form. Alright, so let's go ahead and locate in each column the main operator and the ordering of operators. So obviously this one here, this horseshoe on the second premise is going to be the main operator, and then over here to the conclusion we have 2 operators. Well, the ampersand is only, the range of it is only P and Q, so this one is going to be our first operator we're going to work on, and the final operator, the main operator here, will be the horseshoe. Okay? Again, over here on the first premise, it looks the same, basically kind of has the same format as the conclusion, so the ampersand is going to be our first operator we're going to work on, and the horseshoe here will be our main operator, and it will be our last, it will be the, I should say, the operator that will give us the final value of the statement. Okay, so let's go ahead and begin with our conclusion. Well, again, we're trying to make the conclusion false. We're trying to make this horseshoe false, all right? So we know from our operator tables that if you want to make a conditional statement false, you've got to make the antecedent true, and you've got to make the consequent false. So we're kind of locked in on that. So you have to make, in this case, S false. So we already have our value for S here. And this conjunction here that functions as the antecedent, that conjunction needs to be true. Okay, right? Well, we know by definitions of the conjunction operator table that the conjunction is only true when both conjuncts are true. So P has to be true and Q has to be true, okay, in order to make this whole entire thing false. So this one was pretty straightforward. Immediately in the conclusion we were locked into certain values. So P has to be true and Q has to be true. Okay, so let's go ahead and plug in all those values for the premises. So true, true, and F over here is false. Okay. Well, okay, right away we can see here true ampersand true is going to be true, all right? And okay, so we know the main operator here in the first premise is the horseshoe, and we know we don't want it to be, like in the case of the conclusion where the antecedent is true and the consequent is false. We already know that the antecedent here is true, so in order to avoid getting a false conditional, we need to make R true. Okay, so here we are, we locked into a value here. So true and horseshoe true is going to be ultimately true. So we got that premise to work. So let's go ahead and plug in true for R over here in the second premise. Alright, so we know from our conditional operating table that if the antecedent is false and the consequent is true, then the entire conditional is going to end up being true. So we got the table to work. So we have a true premise here, premise 1, true premise here, and premise 2, and then a false conclusion. So because we were able to get this table to work, then we know then that this entire argument here is going to be an invalid argument.